Okay, so for a trigonometry question, it's on page 409 of the text and textbook. Right, they have given you a picture and they've said from a point A on level ground, the angle of elevation to the top of a tower is 40 degrees. Okay, because they've said it's level ground, you assume this one is flat. You assume, again, it's probably a silly assumption, but you assume that people have built towers correctly, so they go up straight. So this angle here would be a right angle triangle, right, 90 degrees. And in the textbook, they've actually labelled it as such. But in an exam, if it mentions leveled ground, okay, take it that it is a right angle going up for buildings. So you have this picture. So in it, you go, what can I do? I have a right angle triangle. In terms of my right angle triangle, I have a 90 and I have part of a side. Okay, so I can't do my Pythagoras theorem and I can't do my sine, cos, and tan ratio. And then I go, okay, I have this smaller right angle triangle. No, again, all I have is two angles. But read these two angles. I can tell that I have a 90 and this is 60. So I know that this angle up here is 30 degrees. So I have a 90, a 60, and a 30, because you know triangles add up to 180 degrees. They want you to find CD, so they want you to find this length. So we have a right angle triangle and we have three sides on it. If you try to work out this length, we can't do anything yet. So again, you look at your picture. So in our picture, we have that right angle triangle too. So you've got 40 here. You've got 90 here. So what angle is missing at the top? So 40 and 90 will give you 130. So you're missing 50 degrees at the top. We know 30 of it is already used. So that means we know that it is split into a 30 and a 20. Right? So now our path of what we're going to do is getting clearer. So if you look at this triangle now, we have a 50 as a length here. We have a 20 as its opposite angle. We have a 40 and we are looking for this side. So we are looking for CD. So CD is what we're looking for. So CD over the sine of its angle, the opposite angle, is equal to the length, which is your 50, over the sine of its opposite angle. So now what we do is we want the CD on its own. So we leave the CD where it is and we bring the sine 40 up. So you've got 50 times sine of 40 divided by sine of 20. So on the calculator, if you go 50 sine, so 50 sine 40, close your bracket, equals divide by sine of 20, close bracket, equals, you get 93.96. So if you're going to the nearest unit, you'd go, that's 94 meters or whatnot long, units long. And that's our CD. So that's this side. And then you want to find the height of the tower. So for the height of the tower, we now have right angle triangle where this is 94, this is 60, this is 30, this is 90, and we want to work out this one. So for this triangle, you discover it is a right angle triangle. In the right angle triangle, we have angles and we have side. So we cannot find out the length using Pythagoras theorem, but we should be able to work it out using your sine, cos, and tan ratios. So if we take this 60-degree angle, this is its opposite. This is the hypotenuse. So the rule using hypotenuse and opposites are sine. So you go sine of 60 is equal to the opposite over the hypotenuse. So if we want to get the x on its own, x is equal to 94 times the sine of 60. So on your calculator, you go 94 times sine 60, close bracket, equals. And it gives you 47 root 3. If you press your change button, it tells you it's 81.40. So the height of the building is 81. Okay, but that's how you work on the questions. You go, do I have a triangle? Do I have a right angle triangle? If I have a right angle triangle, what can I do? Okay. In terms of ease of steps, you look and see, can you fill in angles by using your three angles of triangle or 180 degrees. After that, you try Pythagoras' theorem, try your sine, cos, and tan ratio, and then do your sine rule. And then go back to the start again and go back. Go, do I have a right angle? Do I have a such and such?